Hi Algebra 2 Honors students, this is Ms. Skokin and we're going to be talking about Chapter 5, Quadratic Equations and Relations. The first section is all about graphing quadratic functions, something that you're a little bit familiar with from Algebra 1 and from our work on the parent functions and the transformations. I'd like you to stop the video now and read the objectives and the vocabulary. In order for a function to be considered a quadratic function, the highest degree term has to be the x squared term. That's the one that we're actually going to call the quadratic term. And if you remember, the parent function is y is equal to x squared. So the x squared term is required. The linear term, the x term, and the constant are not required, but we often see those in a quadratic function as well. And what they do is, you can imagine, is they help move that parabola around the coordinate plane. So we're going to take a look at a couple of graphs of a parabola, and I'm going to pause the video now. I'm going to draw axes, label, scale, and draw the parabolas, so I'd like you to do the same. As soon as it's drawn, you can pause the video, copy those into your notes, and then we'll discuss what the features of the parabola are. So you can see that I've drawn two parabolas. The one on the left is upward facing, and it kind of looks like a smile. The one on the right is downward facing, and it looks a little bit like a frown. Some of the features that we're interested in on the parabola are the vertex, the axis of symmetry, and the intercepts. So I'm going to pause the video now so that I can label my parabolas with those features. Copy those down into your notes. So taking a look at the parabola on the left, we've drawn in the axis of symmetry, and that is just what it sounds like. It's a line that cuts the parabola in half and shows a mirror image on the left and on the right. So it splits the parabola exactly in half. Also on the axis of symmetry, you'll notice, is the most extreme point on the parabola, and that's called the vertex. If you have an upward facing parabola, the vertex is going to be at the very bottom, or the minimum point. If you have a downward facing parabola like the one on the right, then you'll see that the vertex is a maximum. In addition to the axis of symmetry and the vertex of each of the parabolas, you also see the x-intercepts and the y-intercept marked. The y-intercept is the same thing it's always been when we were talking about lines or absolute value functions. It's where we cross the y-axis. The x-intercepts are of particular interest to us because we also, as we learned I think it was in Chapter 1, we talked about how that is also known as the solution or the root of the function, or the solution of the equation. So that's something that we'll be dealing with a lot, and you'll remember your factoring. When you factor quadratics, one of the things that we did is we set it equal to 0 and then solved, and that's in order to find these locations, the x-intercepts. Something we often talk about is behavior of functions. And as you look at the parabola on the left, you can see that we read it from left to right. It's decreasing, decreasing, decreasing until it hits the vertex. And then it starts going the other direction. It starts increasing, increasing, increasing. If you look at the parabola on the right, you can see that that one starts, as we read from left to right, down at the bottom of the graph in negative infinity, and it increases and increases and increases until we get to the vertex. Once it hits the vertex, then it starts going down again. And so that's why we call the vertex the turning point of the parabola. So taking a look at the equation y is equal to ax squared plus bx plus c, remember we have to have that a term, that x squared term, otherwise it's not going to be a quadratic. The y-intercept is always going to be c, that constant value. And why does that happen? Because the y-intercept is when x is equal to 0. And if we plug in x equals 0, the x squared term and the x term both fall out, and all we're left with is y is equal to c, giving us the y-intercept. Another important feature of the parabola we talked about was the axis of symmetry. We can always find the axis of symmetry when the parabola is written in standard form as it is here, y equals ax squared plus bx plus c, by finding x equals negative b over 2a. The axis of symmetry is a line, so it's the equation of a line. It happens to be a vertical line, so there's no y in it, but it's x is equal to negative b over 2a. And we said that the vertex always appears on the axis of symmetry. So the x coordinate of the vertex is the same as the equation of the axis of symmetry. Although when we write the axis of symmetry, it's always going to be in the form of a line, x is equal to negative b over 2a. And when we write what the vertex is, it's always going to be as a coordinate because it's a point, x, comma, y. We already said how we'll get the x. It's going to be negative b over 2a. But how will we get the y? Hopefully you remembered that when we have an x and we need a y, we plug the x into f of x. The x that we're going to be plugging in is the value negative b over 2a. Let's see what this looks like in an example. We have a quadratic function, f of x is equal to 2 minus 4x plus x squared. Well, it's almost in standard form, but not quite, because we need it to be in the order where it's in decreasing degree. That means the highest power on the left and the smallest power of x on the right. So stop the video now, rearrange it, and then identify what a, b, and c are. Once you've rearranged it so that it looks like it's in standard form, you can identify a, b, and c. Now, in these boxes, what we're going to be doing is we're going to be finding the y-intercept, the axis of symmetry, and the vertex in each of those three boxes. So pause the video and try to work it out on your own using the notes from the previous page. Then turn the video back on and check your answers. Remember that the y-intercept is a point, and you need to show it with an x-coordinate and a y-coordinate. Because the x-coordinate is always 0, we know it's easy to find the y-intercept by plugging in 0. It's going to be our c, or our constant. We saw that on the notes on the previous page. You need to be able to show the work and not just recognize that it's the constant term. Now let's try the axis of symmetry. Finding the axis of symmetry is easy once we've identified a, b, and c. Because all we're going to do is use that little formula for the equation of the line that is the axis of symmetry, x equals negative b over 2a. Plug in what we identified for b and what we identified for a. In this case, we get x is equal to 2, which is going to be a vertical line. When we graph the axis of symmetry on our parabola, we're going to show it as a dashed or a dotted line. Now let's try finding the vertex. Okay, so remember that when we find the vertex, we're going to use the same x that we got for the axis of symmetry. Plug that into the f of x, the function, so that we can get the y. And we end up getting the vertex, which is a point. And we have to show, not just the x, but the y. We have to show the coordinates of the vertex. All right, in this next part of the example, we're going to make a table of values to graph the function. Just like we did when we found the vertex of an absolute value function, we're going to find the vertex first so that we make sure and have 2 points to the left and 2 points to the right. That's how we're going to build our xy table. Now, I know that we normally do our xy tables up and down. This one, in order to save space, is shown left to right. So pause the video now. Using the vertex, pick 2 points to the left, 2 points to the right. Plug in the x's that you choose to get the f of x, and then write down the coordinates in the third line of this table. Once you get those, you want to graph in part C, you want to graph the function, including the axis of symmetry and the vertex, and label everything. Pause the video now and give it a try. We'll check answers in a second. So remember that when we pick the x's, we're going to plug into the function, we get the f of x. The f of x is going to serve as our vertical coordinate. So we have our 5 points, and we can move on and graph the parabola using those 5 points. So again, pause the video now, graph the points, and don't forget to label the axis of symmetry, the x-intercept, the y-intercept, and the vertex. Okay, so we've graphed the parabola. We have our axis of symmetry shown as a dashed line. On the axis of symmetry, we see our vertex. That's the extreme point of the parabola, and in this case, because it's an upward-facing parabola, we can see that the vertex is a minimum. We also show the y-intercept, where the parabola crosses the y-axis, And the x-intercepts, in this case there are two that show the roots or the solutions of this parabola. All right, let's take a look at the next page of notes. We've got another example to work on. I'm going to have you work on that and then check your answers when you turn the video back on. So for part A, we're finding the y-intercept, the axis of symmetry, and the vertex. The first thing that we need to do is make sure it's in standard form. It is. And then we identify the A, B, and C of standard form. So A is equal to 1, the coefficient of the x squared term. B is equal to 3, the coefficient of the x term. And C is our constant, -1. Then, going back to the definition of y-intercept, we know that that means that x is equal to 0. We plug in 0 for x, and our f of x is going to be -1, which was our constant. Remember, the y-intercept is a point, and we show it with an x-coordinate and a y-coordinate, 0, -1. To find the axis of symmetry, we're going to use the formula for the axis of symmetry. Remember, it is a line. X is equal to -b over 2a. X equals means that it's going to be a vertical line. So we plug in the values for A and for B into our formula, and we end up with x is equal to -3/2. That's the equation for the line that is our axis of symmetry. Using that same x value, we're going to plug into the function and find the y. That x and y combination gives us our vertex. Now let's move on to part B and make a table of values to graph the function. Remember, the vertex is the middle point. We're finding 2 points to the left and 2 points to the right so that we can get the full shape, the left-hand side of our parabola, and then the vertex, and then the right-hand side of our parabola. Okay, here's the xy table. Once we've got all of those x's, remember the vertex, 2 to the left, 2 to the right, we plug those into the f of x, we get the y's. Now we're ready for graphing. So once again, after you've checked your points, pause the video and graph your function, which is going to look like a parabola. Remember to please label, whether it's upward facing or downward facing, label the x-intercepts, label the y-intercept, label the vertex, draw and label the axis of symmetry. We definitely have an upward facing parabola. We can see the x-intercepts where it crosses the x-axis and the y-intercept where it crosses the y-axis. We've got our axis of symmetry, a line labeled and shown as a dashed line. Remember, always vertical. And we see that our vertex in this case is a minimum because we have that upward facing parabola. On the next page of notes, we're going to find out how we can predict whether the parabola is going to be upward facing or downward facing. When our a term, that x squared coefficient, is positive, we're going to have an upward facing parabola. When the a term is negative, we're going to have a downward facing parabola. When we have a downward facing parabola, remember our vertex is going to be a maximum of the parabola of the function. And when we have an upward facing parabola, the vertex is going to be a minimum of the function. There are a couple of little questions at the bottom of those boxes. Does f of x have a maximum value on that upward facing parabola? The answer is no, because the y values increase without bound. They keep going to positive infinity. And similarly, when a is negative and we have a downward facing parabola, there is no minimum value because the y values decrease without bound to negative infinity. We've got another example, and I'd like you again to pause the video, work on this example, and then check your answers when you turn the video back on. Okay, so when we're finding whether or not the function has a maximum or minimum value, remember we're referring back to that value of a, the x squared term. In this case, the x squared coefficient is -1. A is -1. That's a negative number, so we know f of x is going to open downward. Since it opens downward, it's going to have a maximum value at the vertex, but it's going to have no minimum value. And to find the maximum, what we're going to do is find the vertex. It's always going to be the most extreme point on the parabola. We already identified a, it's -1. B is 2. So we plug into our formula to find the x coordinate of the vertex. X is equal to -b over 2a, and we get x is equal to 1. We plug that back into the function and get f of 1 is equal to 4. So the maximum value of the function is 4. That's it for the 5.1 notes. See you in class when you're going to be working on practice problems.